Hello friends, uh, welcome back to my channel. Today I came up with assignment 7 solutions. I know I'm a little bit late this week, but still we have 3 more days to go to submit this assignment 7. We'll quickly see the question and answers of the assignment 7 of big data computing. Okay, fine. So this week they have given only 8 questions. The first question is which is true or false. The bootstrap sampling method, the bootstrap sampling method is a resampling method that uses random sampling with replacement. That is true. The statement is true. So the appropriate answer for this is the first one. Second one is also a true or false statements. They have given 2 statements. We have to identify which are all true or false. The first statement is maximum likelihood estimation is a method that determines values for the parameters of a model. The parameter values are found such that they maximize the likelihood that the process described by the model produced the data that were actually observed. That statement is true. Second statement, bagging provides an averaging over a set of possible data sets, removing noisy and non-stable parts of the models. Yes, this is also true. Bagging removes the noise and other things from the data sets. So both statements are the true. Both statements are true. Coming to the third question, in which of the following scenario a gain ratio is preferred over information gain? They have given for three different answers. When a categorical variable has very small number of categories, no, it is not correct one. And the second one is when a categorical variable has very large number of categories. Yes, we will be choosing gain ratio over the information gain when the categorical variables are very large. Then only we'll choose gain ratio over information gain. So the appropriate answer for this is the second one. Coming to the fourth one, this is a problem actually. They have given some data set. And they have in the data set we are having actually 4 attributes. If you observe, we are having outlook, humidity, wind, and the other one is play, the label. They are asking us to find out the root node actually. Which of the following attribute will first provide the pure subset? Meaning they are asking the root node of this, which is a root node. I mean, they're asking us to either use a decision tree algorithm. I mean, in this for this problem, I'm using the decision tree algorithm. Specifically, I'm using ID3 algorithm to find out the root node for this. So we'll be solving this problem. I'll be showing how to solve this problem. If you observe, they have given 4 attributes. Totally we are having 4 attributes: outlook, humidity, wind, and play. These are the 4 attributes they have given. They are asking us, play is actually, this one is a label. Okay, so attributes are 3 and this is a label actually. So total attributes are 3. Among the 3, which one will act as a pure subset, meaning which is a root node for this particular tree they're asking. So I'm going to explain how to solve this problem now. Give me some time. I'll be opening the document which I prepared. Yeah. This is the data set they have given. Attributes: outlook, humidity, wind are the attributes, and this is the label. Okay, this is a data set. Data set contains attributes as well as the labels. Few data sets won't contain the label. There is different thing. I'm not going to discuss all those things now. From this data set, what I have taken is number of positives and number of negatives. If you observe the label, there are completely in the data set they have given 14 records are there. If you count the records, we count the record numbers, there are totally 14 records are there. Okay, so total is 14 records, 14 rows are there, and that the positives are 9 and the negatives are 5. S is 5 and no's are, sorry, S is 9 and no's are 5. If you count in the data set, it will be coming that I'm calling it as P, positives, N is negatives. We have to find out that first for the given label. In the given label, how many are the positives we are having, how many are the negatives we are having, that we need to count it and put it aside. Then later, the procedure to find out the root node is, I have given the procedure also. If you want, you can go through. At first, I'll be computing the entropy. I have to compute the entropy for the given data set. I need to find out the entropy for the given data set. That's the first step we need to find out. How to calculate the entropy, I'll be showing you the formula also. The next step is for each attribute. How many attributes we are having? We are having 3 attributes. One is outlook, temperature, the second one, the third one is wind. For each attribute, we need to find out the entropy, and we have to calculate the average information entropy for each attribute, and finally we have to calculate the gain also. Okay, these 3 things we need to find out for each attribute. Okay, after finding out this, we need to pick the highest gain attribute. Whichever the attribute having the highest gain will be our root node, will be our pure subset. Okay, so this is a procedure we are going to do on the given data set. The first one is find out the entropy for the given data set. Finding out the entropy for the given data set means for the label we'll be finding out the entropy. So the entropy formula is, I've given the entropy formula here. Okay, entropy formula is minus P. P is positives, N is negatives. Minus P by P plus N log base 2 of P by P plus N minus N by P plus N log 2 N by P plus N. This is the formula of finding out the entropy for any given attribute or values. Okay, P is positives, which we already know the values. P is 9 in this case and N is 5 in our case. Okay, we already know what is P and what is N. Substitute all those values. P is 9. Okay, and P plus N, 9 plus 5 is 14. Okay, log base 2 of 9 by 14 minus N is 5. Number of nodes in our given data set is 5. So 5 by total is 14. So log 2 5 of 5 by 14 is equal. So we'll be getting the entropy as 0.940 is the entropy of the given data set. So for the first step we have done. In the first step we are going to calculate the entropy of the given data set. Calculating the entropy of the given data set means we are finding the entropy for the label. Here the label is plain. Okay. After that, for each attribute I need to calculate the entropy. We are having 3 attributes. For each attribute I am going to calculate the entropy now. Okay, so the first attribute, let us take the first attribute is outlook. If you observe the data set, the first attribute is, which is the first attribute? The first attribute is outlook. Okay, so for this attribute I am going to find out the entropy, the average information thing, and the last one is gain. These 3 things I need to calculate for this attribute, and for this attribute. Okay, fine. If I take this attribute, if you observe in this attribute I am having 3 different values. What are those 3 different values? One is sunny. If you observe, one is sunny. The second one is overcast. The third one is rain. I'm having 3 different values in this attribute. So for these 3 different values, I need to calculate the entropy. I have to find out the average information gain, and gain I have to find out. Okay. So let's take the first value, that is sunny. Okay. Now I'm taking the sunny value, and later I'll be calculating the entropy for overcast, and I'll be calculating the entropy for rain also. Okay. Fine. Now let's see, I'm given the entire information in the tabular format. Yeah. If you take here, I have taken the outlook attribute. For outlook attribute, I've taken I told that there are 3 different values: sunny, rain, and overcast. I've taken all those records which are having sunny, and I have specified its label value also. Okay, from the data set you can find out the labels. For first sunny the label is no, and for second sunny the label is no. For third sunny also the label is no. For fourth sunny it is yes. For fifth sunny it is yes. Okay, so likewise I have segregated the given attribute values into 3 different things. Okay, similarly rain. For rain the corresponding the corresponding labels I have specified here. Okay, similarly for overcast I have specified the label values here. Later, after having this information, now I can find out the entropy of these different values. Okay, fine. If you see here, this is the attribute name, outlook, positives, negatives. The entropy I have calculated here. If I take sunny, in sunny, how many positives are there? 2 positives are there. In sunny, there are 2 positives, so 2 positives. How many negatives are there? 3 negatives. So I have taken 3 negatives here, and substitute these values in the entropy formula. We know the entropy formula: minus P by P plus N log 2 of P by P plus N minus N by P plus N log 2 of N by P plus N. That is the entropy formula which I have given in the same document. You can go through, substitute the given values in that formula, and we'll be getting the entropy value as 0.97. This is the entropy value we got for this value, sunny. Similarly, for rain, if I take, in the rain, we are having 3 positives, 1, 2 and 3. Negatives are 1 and 2. So the same thing I have specified here. So you can substitute these P and N values in the given entropy formula and calculate the entropy value. We have got the entropy value as 0.971. Similarly for overcast. In overcast, if you observe, all are positives and we don't have any negative values. So 4 and 0. 4 are positives and 0 are the negatives. Entropy will be 0. Okay, if you substitute the values in the given formula, we'll be getting the entropy as 0. So I have find out the entropy till now. And the second step is I have to find out the average information entropy of that particular attribute. I have to find out the average information entropy for this attribute, for outlook attribute. For that, the formula is, I have given the formula. Positives of sunny plus negatives of sunny divided by total positives plus negative. Don't confuse with this. Here I am taking only the positives of sunny and negatives of sunny divided by positives of the total data set, negatives of the total data set. P means total data set I am representing. N means the total data set negatives I am representing. Into entropy of sunny plus positives of rain plus negatives of rain by P plus N into entropy of rain value, rain related entropy. And overcast also I have taken. This is a formula to calculate the average information entropy of the given attribute. Okay, friends, fine. Now substitute the values. We know what is P of sunny and plus N of sunny. 2 plus 3 by, if you observe from the table, you will be getting all these values from the table only. See, P of sunny is 2, N of sunny is 3. Divided by the total P is 9 plus 5. 2 plus 3 by 9 plus 5 into the entropy of sunny we got is 0.971. From the above table, you can derive all those values and you can put it in this formula. Plus P of rain by plus N of rain. We have it same. Take the values from the table and substitute all those values in the given formula. We'll be getting the average information entropy as 0.693. This is the value which we got in this case. The third step is calculate the gain. The gain formula is entropy of total data set minus information, average information entropy of the given attribute. This is a formula of gain. Okay. So total entropy of data set, how much we got? If you go up, the total entropy of the data set is 0.940. Okay. So 0.940 minus, for outlook we got the average entropy value is 0.693. If you observe here, 0.693 is the average information entropy we got. So substitute in the given formula, we are getting the gain as 0.247. This is the gain value we got for outlook attribute. Okay. Similarly, for the next two attributes, we are having two more attributes. One is humidity, another one is wind. Similarly, follow the same procedure for this attribute also. Calculate the entropies for each values, find out the average information entropy, and calculate the gain value. So again, draw the same tables. If you observe, in humidity, if you go up in the for the data set, in humidity, if you observe, in the humidity attribute, we are having only two values. One is high, another one is normal. For high, take the positives and negatives, and for the normal also take the positives and negatives. Draw a table. It will be easy for you to calculate the P's and entropies. See, for humidity, the normal and high I have taken, only two values we are having. So for normal, how many normals are there? The corresponding label value specify here. Similarly, for high also specify the label values, and from this you can derive one more table. For normal, how many S are there? 6 S are there. And for normal, how many negatives are there? From this table you can calculate there is only one no is there. By calculating these values in the entropy formula, we'll be getting the entropy for this value is 0.591. Similarly, for high also, take the positives from this table and negatives from this table, put those values in the given formula and find out the entropy. After finding out the entropy for these values, the second step is calculate the average information entropy. The formula for calculating the average information entropies I have given in the before pages, I mean in the same Word document. This one, 6 plus 1 divided by 14 into this entropy plus 3 plus 4 divided by 14 into this entropy value. Okay, we'll be getting the information entropy as 0.778, and the third step is calculate the gain. The gain is the original entropy value of the entire data set is 0.904 minus the attributes average information entropy value. We are getting 0.152 as the gain value. Similarly, for the next attribute also follow the same procedure for wind attribute also. In wind attribute also we are having only two values. One is strong, another one is weak. For all weaks, take all the label value. Similarly, for strong also take write down all the label values. From that you can calculate the P's and N's and also the entropy. Substitute all these values in entropy and you can get the entropy values. After that, find out the average information entropy. We are getting the average information entropy as 0.892, and after finding out this we can calculate the gain. The gain formula is the entropy of main data set minus the attribute entropy value. So we are getting as 0.048 as the value of this particular attribute. If I write down all these gain values here in a table, I have taken the attributes. The attributes we are having it as, we have to pick out the highest gain attribute from this table. Attributes are outlook, humidity, wind. We got the gain values as 0.247 for outlook, 0.152 as humidity, and for wind how much we got? 0.048 is the gain value. If you observe from this table, which attribute is having the highest gain? Outlook is having the highest gain. Okay, from this table we can say that outlook is having the highest gain. So outlook will be the pure subset for this particular problem. It will act as a root node for this problem. Okay, fine. Okay friends, so the pure subset is outlook. If you go back to the our problem, they have asked, like they are given this data set. Which of the following attribute will first provide the pure subset? First pure subset they are asking. First root node they are asking. So outlook is the appropriate answer for this question. Okay, fine. Next, fifth one. Hundreds of trees can be aggregated to form a random forest model. Which of the following is true about any individual tree in the random forest? They have given 4 things about random forest. We have to find out the truths. Which are the true statements? Individual tree is built on a subset of the features. That is true. Individual tree is built on all the features. No, it's wrong actually. Individual tree, we won't build it on the all features. Individual tree is built on a subset of observations. It is true. Individual tree is built on full set of observation. No. So the answers are the first one and the third one is the appropriate answer. So the option is the first one, 1 and 3. The sixth question is, which of the following are true about random forest and gradient boosting ensemble methods? Okay. They have taken 2 ensemble methods. One is random forest and the one is gradient boosting. They are asking out to find out some true statements about those 2 methods. Both methods can be used for classification. Yes, both methods can be used for classification. Random forest is used for classification, whereas gradient boosting is used for regression task. Is used for classification, whereas no, actually both can be used. No, random forest and gradient boosting both can be used for both tasks. So the second statement is false. Random forest is used for regression, whereas gradient boosting is used for classification task. No, both can be used for both purposes. Both methods can be used for regression task. So the first and fourth one is the appropriate answer. Both can be used for classification, both can be used for the regression task. So the appropriate answer is the third option, that is 1 and 4. Coming to the 7th question, boosting any algorithm takes into consideration the weak learners. Yes, which of the following is the main reason behind using weak learners? To prevent overfitting. To prevent overfitting only we are going for weak learners. So the reason 1 is the right one. So first option is the correct one. Coming to the last question, to apply bagging. To apply bagging to regression trees, which of the following are true? We build the n regression with n bootstrap sample. Yeah, we can build. We take the average of n regression tree. Yeah, it's true. Each tree has a high variance with low bias. Yes, it is also true. So the answers are the last one, 1, 2 and 3. Okay, fine. So friends, that's all. You can submit your answers. If you have any doubts regarding any question in the assignment, please post it in the comment section. I'll be answering to your questions. And one more thing, as tomorrow at 10 a.m. is the last day to register, to get registered. So please go ahead and get registered to this course. And we are having the exam in December. And we'll be having one more assignment, assignment 8. In the next video, I'll be coming up with assignment 8. This time I won't be late. I'll be uploading at proper time only. I guess I'll be uploading in the proper time. And if you have any doubts related to big data, please put it in the comment section. I'll be answering to your questions. So that's all, friends. We'll meet in the next video. Thank you. Have a nice day.